Welcome to the Vision Campus. Software is a fundamental component of digital image processing. An acquired digital image is transmitted, displayed and stored by software. Also, the analysis of digital images is carried out by software in image processing. We would like to shed light on the software functions from image acquisition to image analysis. Even when preparing for image acquisition, software plays a role. Camera parameters such as the length of the exposure time or gain and offset are usually controlled by software. In the camera itself, the first pre-processing steps are often performed on the raw data from the sensor after image acquisition. For example, to correct image distortions or to influence the characteristics of the sensor. These software components are called camera firmware. Transmitting image data from the camera to the image processing computer quickly and reliably is not a trivial task. Here too, software components play an important role by implementing the rules, also known as protocols, according to which the camera and the computer work together. A well-known standard for such protocols is GenICam. After the image has been received in the computer, a piece of software called GenTL Producer transfers the image to software applications for further processing. Any processing software can connect via a piece of software called GenTL Consumer to any GenTL Producer and receive the image for further processing. Now it's time for image processing, to extract the required information from the image. The first step is to emphasize certain image features, such as edges, or to apply thresholds. This makes it easier to detect, count and locate objects on the image. Sometimes it is also necessary to measure object dimensions and distances or image areas precisely. Furthermore, neural networks can detect structures on the image. This allows actions such as classifying objects or whole images as faulty or error-free. Often it is also about recognizing text or decoding codes on an image. Image analysis is a demanding task that requires the highest speed and accuracy, and thus very efficient software architectures. The path of the image from the camera to the processing computer, as we have described it, can vary depending on the vision system. In smart cameras, for example, the image is processed directly in the camera itself. A smart camera for barcode recognition only passes the decoded value of the barcode to the connected processing unit, instead of the image with the barcode. In high-speed vision systems, the image is often received in the processing computer by special hardware cards, known as frame grabbers. They often perform the first processing steps on the image before the image is passed to the processing computer. This lowers the performance requirements for the processing unit. Alternatively, the complete processing can take place in the frame grabber. For example, image classification using a neural network. In this case, the frame grabber would forward the result of the image analysis to the processing computer along with the image. In conclusion, digital image processing means image processing by software. From the control of the image sensor itself and the pre-processing of the acquired raw image data through the transport of the image between different subsystems and up to the analysis and storage. This takes place depending on the system structure within a camera or across several subsystems. We have seen the path of an image in digital image processing and the variety of possibilities that digital image processing creates. Let's use them. Thanks for watching.